Hi, my name is Dave Weimer. I'm in the Computer Graphics Lab, which is part of the Machine Perception Research Department at AT&T Laboratories. I'm going to demonstrate our work on three-dimensional graphical interfaces. The interface you will see features hand tracking and speech recognition. The entire system consists of the following. A VPL DataGlove is used for tracking the hand. A prototype keyword recognizer with a 26-word vocabulary recognizes spoken commands. An AT&T Pixel machine is used for computer image generation. And a Sun 3260 is the host computer. The interface paradigm that we use is oriented toward applications in computer-aided design. The DataGlove is used to control a computer model of the hand, shown here as a collection of spheres. The interface makes use of the orientation of the user's hand. The position of the index fingertip is used for pointing and dragging. Pointing is used to select control points. Pointing is used for menus. And dragging is used for defining curves. The only static hand gesture that is used is based on the abduction angle of the thumb. This gives the user something similar to a mouse button. When the thumb is held out, there is no gesture. As it is pulled toward the hand, the first threshold triggers a clutch gesture. The second threshold triggers both clutching and picking gestures. The picking gesture is used for menu selection. The clutching gesture is used for incremental rotation of objects. Keyword recognition is equally important because it allows the user to start or stop operations, to turn on or off options without ever having to invoke a menu. That extra communication channel for interacting with the computer allows the user to issue commands even when the hands and eyes are busy. This next example will demonstrate how dragging, pointing, and keyword recognition are used to sculpt surfaces by repositioning control points. The surface normal vector is used to constrain the motion of control points. Vector. Vector. Okay. Point. Drag. Vector. Vector. Okay. Rotate. The next example shows how speech and hand tracking are used to define cubic b-spline curves. Okay. 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 Close. We can use curves in a sweep operation to define surfaces. In this example, the curve follows the position and orientation of the hand. The keyword OK drops a copy of the curve, extending the surface of cubic b-spline patches. Okay. 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 Quit. Other methods of sweeping curves include vector swept curves, curves swept along other curves, and rotational sweeps. Sweep. Let me close by describing the future of this work. We are extending the interface to include multi-user capabilities. A shared three-dimensional workspace could provide the basis for collaborative engineering systems. These systems would allow design teams to transform ideas into products more quickly. So the thrust of this work is in two areas of research. One, improved interfaces for dealing with three-dimensional environments. And two, better representations that enable communication within shared environments.